So when we're building these incredibly powerful tools, especially on a cloud platform, we have to give them permissions to do their job, right? But how do we make sure those permissions don't accidentally open up a huge security hole? Well, today we're going to break down exactly how to lock down your tools using a fundamental security concept, the principle of least privilege.
This quote right here, it really just says it all. The single best defense you have for building systems you can actually trust is to give a tool only what it absolutely needs to function. And look, this isn't about hobbling your tools. It's about being incredibly smart and deliberate with the power you grant them.
So let's get the formal definition on the table. The principle of least privilege is, surprisingly simple. It just means that every single part of your system, every tool, every user, should only have the bare minimum access to information and resources that it needs to do its specific job. No just-in-case permissions. Think of it like this. You're giving someone the key to one specific office, not the master key to the entire skyscraper.
Okay, but why is this such a big deal? Well, the payoff is massive. First off, it shrinks your blast radius. If a tool ever gets compromised, the attacker can only do what that tool could do, the damage is contained. It's also absolutely critical for staying compliant with regulations like GDPR. Plus, it just builds trust with your users because they know you're being careful with their data. And honestly, it makes your life easier. Debugging is so much simpler when you know exactly what a tool was supposed to be doing.
Now, to really put this principle into practice, you've got to think in layers. We're going to look at 4 key models for controlling access on your platform, and when you use them together, they create this really strong, multi-layered defense. These layers all work in concert. At the very top, you have tool-level permissions. This is where the tool itself says, hey, I need to be able to read the file system. Simple enough. Then you get more granular with resource level, which controls access to a specific piece of data. Below that is user level, which you probably know as role-based access control, or RBAC. That's about what the person can do. Are they a viewer, an editor, an admin? And finally, the most advanced layer is attribute-based access control, or ABAC, which adds context. Things like, is it business hours or are they in the right country, for super fine-tuned control.
Okay, so that's the theory. We get it. But how do we go from these concepts to actual code? Let's get into the nitty-gritty of how you can implement this step by step. It really boils down to these 3 crucial moves. First, you have to know what you're dealing with, so you classify every single tool based on its potential risk. Is it basically harmless, or could it burn the whole house down? Once you know the risk, you can define its boundaries. What is the absolute minimum it needs to do its job? And finally, the most important part, you implement checks in your code to actually enforce those rules. Let's zoom in on that classification step, because it's so foundational. Low-risk tools are pretty much read-only, like listing files or searching a database. They probably don't need any special approval. Medium-risk tools are things that make safe changes, like sending an email. Here, getting an approval is probably a good idea. But then you have the high-risk stuff. We're talking destructive actions like deleting a customer record or dropping a whole table. For these, you should always require a human to sign off. No exceptions. So where do we enforce this stuff? Well, your first line of defense happens the second your server starts up, before a single tool even thinks about running. You do a broad check. Does this user's role even have the type of permissions this tool needs? It's a fantastic first filter to just shut down unauthorized access from the get-go. But that first check is just the bouncer at the main door. The real security happens at the moment of truth, right when the tool is invoked. Every single time a tool gets called, your system has to ask 2 questions. 1, can this user use this tool? And 2, can they access the specific thing it's trying to touch? This is what stops someone with general file access from peeking at a restricted HR document. It's absolutely critical. All right, once you've got those basics in place, you can really start to level up your security game. Let's talk about some more advanced techniques that give you even more fine-grained control. I love this example of allow list and deny list. It's so clear. For a tool that works with files, you can say, hey, you're only allowed to play in the /workspace and /docs folders. That's your allow list. But at the same time, you create a deny list that says, and you are absolutely forbidden from touching anything with secrets in the path, or any .env file, period. It's that powerful combination that really locks things down. So we've mentioned getting human approval, but what kind of thing should trigger that? Well, obviously any destructive action, but you should also think about actions that affect lots of records at once, or anytime a tool tries to access sensitive info like personal data or financials. And don't forget high-cost operations. A bulk email send or a massive database query can cost real money, so it's a good idea to have someone approve it first. And this is what that whole approval dance looks like in practice. The tool tries to do something sensitive. The server catches it and says, "Whoa, hold on, this needs approval." It then pings the user's screen with a pop-up dialog. The user gets to look at exactly what's about to happen and make the final call, approve or reject. Only if they click approve does the server go ahead and do the thing, making sure to log that decision, of course.
And here's something that's super important but often gets forgotten. Rate limiting is a form of permission. Yeah, really. By deciding how often a tool can be used, you're basically granting it permission for a certain volume of actions. This is so crucial for stopping abuse, managing the load on your system, and keeping your costs in check.
Okay, last piece of the puzzle. You can have the most amazing security setup, but if you can't prove it or see what happened after an incident, you're basically flying blind. That's where good old-fashioned auditing and logging come into play.
A useful audit log is all about what you put in it. You for sure want to log the tool name, what it was trying to do, who did it, when they did it, and whether it worked or not. But, and this is a big but, what you don't log is just as important. Never, ever log passwords, API tokens, or big chunks of sensitive user data in your logs. That just creates a whole new security risk.
Let's bring this all home with a super practical example. Imagine a customer support tool. Searching for tickets, that's low risk, so you give it a nice high rate limit, no approval needed. But deleting a ticket, whoa, that's a high risk action. So that requires an admin, it has to go through that approval pop-up we talked about, and it's got a very low rate limit. See how all the layers come together to protect the system? It's pretty cool.
So as we wrap this up, I want to leave you with one big question to take back to your own projects. Your tools have access, they have to. But the real question is, do they have too much access? Taking the time to apply the principle of least privilege isn't just checking a box for security best practices, it's about fundamentally building systems that are secure right from their core.